Hello everyone, welcome back to Computer Aided Measurement and Control class in 13 weeks. In this online lecture, we still study in Matlab Simulink, and today you are going to learn how to deal with the analog input, especially analog input and output. Okay, next is objective. Understanding still Matlab Simulink, especially to program Arduino Uno. And to deal with the analog input-output. In previous lecture, we studied a digital input-output, right? I hope you understand a digital input-output. Now, we are going to study analog input-output in Matlab Simulink. All right, and the devices we need in here, of course, Arduino, you know. And the best way to learn analog input-output is use the potentiometer, of course, and we still have to do maybe LED for getting output and not getting output to represent the output signal using LED. And also we have in here sensor LM35 may be useful for temperature measurement, is standard cartridge temperature, and RGB LED to see the and you know the pulse width modulation. We want to output the signal for PWM especially, right? So I just remind you again how to get the support package. I think this one you already know. Install support package for Arduino, Matlab, and also for Simulink. Okay. And to start the Simulink, we have to select this icon and here in Matlab. And I wish you don't have any trouble to install in Matlab. And to create the blank model, you just select the blank model in here. All right, and Simulink graphical user interface. To select library, you have to select this icon. Okay, I hope you already know this one. And this one is kind of standard function for Arduino add-ons. There is a digital output and also digital input. And now we are going to learn the analog input, especially, and pulse width modulation. And in the library browser, using analog input in this diagram block, in the Simulink support package for Arduino hardware, you just select command. In here for analog input, you already know the pin A0 to pin A5 in this region, in this pin, in this part of Arduino, okay. So next is I just remind you what is the analog signal in this PPT. I wish you don't forget about the analog and digital signal. What is that? This analog signal is we call it usually a continuous signal. Okay, everybody agree, right? And the digital signal is also call it the digitized or discrete signal. What is discrete signal? It's just like this: the high and low output voltage. High and low consists high and low. In analog signal, it is like a continuous signal. So the Arduino usually using analog to digital converter or ADC to digitize this signal, and something like this. All right, to measure the how much value of the analog input signal. Okay, in the analog input in Arduino, because the voltage level is from 0 to 5 volts, this voltage is translated to decimal value from 0 to 1023. Okay, everybody already know, right? And the analog output translate the 8-bit number from 0 to 255. Okay, everybody already know this, right? So let's begin for experimental one. Analog input in Arduino Uno. The best way to analog input to detect analog input is using the potentiometer. Everybody already know, right? Potentiometer. This one is variable. We call it also variable resistor, whatever. In this case, has the three kind of port, which is in the middle goes to the A0. Okay, and this right side goes to 5 volts, and bottom is goes to ground. Very simple connection. Okay, everybody. No have trouble with this, I hope so. And connect to A0 and A5. I'm sorry, 5 volts. And also connect to ground. Excuse me. Okay, let's open Matlab 2018. If you install newer version 2020 is okay. I think it's better Simulink model. I think newer version is better. But make sure your Matlab is the original use, not pirated. Okay. So just go plus new in here if you already install Matlab, and open Matlab and select to begin the Simulink model. Select new in here and go to the Simulink model, and it will pop up this graphical user interface, and you choose the blank model. For create a new Simulink diagram block, of course. Okay, for experimental one, diagram block is very simple. First, you choose the analog input, drag and drop to the blank Simulink from the library. And because potentiometer choose in analog A0, so you double click this diagram block, and it will show the analog input number means 0. It means A0. If you select 1, it means pin A1, or if this pin 5, it means that one A5 port. I wish you understand. Okay. For the sample time, this one is get the sample in every 0.1 second. It depends on you. You select this one. 1 second is fine, or 0.01 is fine. In this case, we just get the sample value every single time in one data for 100 millisecond. Okay, and to see the output from digital or decimal value from analog input, sorry, not digital, this one is analog, from 0 to 23. Okay, everybody understand, right? Because this one is 10 bits number. And to see that, you need the scope in here. how to get scope, you can go to this library browser and go to the Simulink from the first option in here, and you can see the sync in here, and you can select the scope in here, scope, and also display. This one is display. If you want to see the number in here, you can select a display, same sync source, select display. First select Simulink and go syncs or display, or this scope is also available in commonly used blocks. Okay, from the scope you can double click this one scope, and this one appear the like scope, like oscilloscope, this kind of the graphical user interface to see the data and or graphics. Especially you want to see the number of the in output, I mean result, number of result from analog input. Anyway, that one is diagram block from this Simulink model. And you can select the configuration for the scope by select this kind of icon in the left of top for setting. You can choose this one first, open simulation start in here, and the sample time must be similar with the analog input sampling time. We set 0.1 previously and should be same 0.1 in here, of course. And you can select the time type here. In the time type tab, and you can choose this time span of run action scroll in here, or time units, second, whatever. And for display, choose this display. You can arrange the minimum value for y-axis 0 and maximum limitation for maximum 1024, and you can label it and name it as decimal value. All right. And in the Simulink, to start with, before started, you should go to tools and run on target hardware and prepare to run. Okay, and in here it will pop up this GUI, and if you find comport your Arduino is usually can run automatically, but sometimes it doesn't connect it. You can set manually your serial port during connection, and you should check the connection for Arduino in your computer. And of course select your type of Arduino. In our case we use Arduino okay. And to begin the simulation, you have to create the time in here, in this case using infinite, and simulation using external devices. Okay, select external device, and for time, infinite time. To begin the simulation, sorry, laser pointer, I think is better. To run simulation, you just click this icon, and you will have some kind of output value, or input value from analog input A0. During when you rotate potentiometer, you will have the discrete voltage or discrete decimal number here from scope. I have some kind of video in here. This one for next to potentiometer, and during running the Matlab Simulink and rotate the potentiometer, it will show the value of analog input of potentiometer. Okay. I think this one is very simple. Okay, from this video you can see the variation of voltage when the potentiometer is rotated. Okay, what is next experiment? Alright, for next experiment you have to convert in here, because this analog input is a number of you already know. I think this one is from 0 to 1023. We have to convert this number to 0 to 5 volts. So just using gain in here, insert gain and put in the maximum value of 5, because this reference voltage default is 5 voltage, divided this one decimal number 1023. To get the gain diagram block, you can choose in here Simulink and commonly used block, and there is gain appear in here. Okay, and this one will display 5 volts voltage analog from analog input A0 pin. Okay, I wish you understand in this. You just convert decimal 23 using this gain. We convert to 5 volt, and then we display to the scope. Okay, and this one is configuration for the scope. We just change the value in here 0 and maximum 5 voltage, and show time axis label if you want to show this kind of label in the scope. Okay, okay, and for this video you rotate the potentiometer after running simulation. You can see the analog voltage input in the scope. Okay, I will show you in a real in here. This one is presentation. Maybe can, oh, this one for next experiment. Maybe can this chart, and I already install everything in here for today experiment. Okay, we have analog input A0 and connect to potentiometer in here, and also have the LED for pin 13, and also for temperature measurement. In here I connected to the A2 pin in here, analog input pin 2, and we also use the RGB LED for today lecture. And I don't create a new Simulink in here. Okay, I open the Simulink and we just create the simple analog input for Arduino. So select in Simulink support package and common. All right, and maybe you can add right click instead of drag and drop. You can add block model. Okay, and also maybe in here scope, also in here usually, or you can go to sync and go to scope, maybe add this and also add this. And I will go through to using gain. Maybe directly I will use gain in this uh, introduction. So you have this one is analog input in this diagram block, and you also have a gain, and you have also display. You can go to the view and zoom it and go to fit. Okay, first thing to do, you have to decide the pin number. Okay, and sample time, I mean in our case we use 100 millisecond for sample time, and this one is conversion from value decimal value. Okay, using gain. And in oscilloscope we can setting in here, click this icon, you can select open at simulation, and the input ports also say 1 because the input is 1. Okay, we select sample time 0.1 for 100 millisecond. Okay, and for time you can select the scroll in here, time span of run action, and time units is depends on you, metrics or second. You can show time axis label, and in here we have the, let's set 5, and we already have voltage in here for our simulation, and go to apply. This one data logging, I think on it. Okay, I think we can close this one, sorry, and connect this diagram block each other. Okay, after this you can go to the tools and prepare to run, tools, run on target hardware, and prepare to run. Of course we use Arduino Uno in our video in here. Okay, in our lecture we use Arduino Uno, and there is the target hardware resource in my notebook. It's connected connected to the COM5, so I set manually in here COM5. So okay, don't forget in here you have to select external mode. Okay, don't forget in here, and maybe I will do simulation for 1 minute, so just select 100. I will do simulation for 1 minute, I think is enough. Okay, and I think just do run. I wish everything is okay. Now doing compiling. Okay, in here, now simulation will running, and it display the scope in here. As you can see, the scope in here and the value how to display in this correctly, like maybe like this. This one value 0 because I don't rotate the potentiometer. If you want to rotate value, this one will follow the input number. It will run for 1 minute because I set for 1 minute. Okay, I rotate potentiometer and the value analog input follow the rotation of potentiometer. It's almost finished for 1 minute. Okay. Okay, go back to presentation. Okay, just leave it this. That one is analog input from Simulink. We can simulate the analog input and using external condition in here. And in this case, in this video, using infinite time in here, we can get the input value from potentiometer using Matlab Simulink. Okay. Okay, for this next video, I will cut this. I will continue for next video. Okay, welcome back. And for second experiment, still using Matlab Simulink. And here we want to use temperature measurement. Maybe we already done this in previous lecture, but using Arduino IDE. In this case, we want to use Matlab Simulink, that is using diagram block, to measure temperature. Before that, I want to remind you what is the LM35. Basically, LM35 is the temperature sensor and is very basic and linearly proportional with voltage. I mean, the temperature is the linear and proportional to the voltage. And it has a resolution about 10 millivolt. Okay, and for 1 degree changing, it means there is a changing of 10 millivolt. And we can operate in here around 0 to 100 degree centigrade. And this one is a connection of the view of LM35, which is the right side of pin is for 5 volts, and this one is signal in the middle, and the left, sorry, this one is left, this one is right. I'm sorry, this one is right. For this one is negative. Anyway, this one is a connection from LM35. You understood, right? And the input for analog usually from 0 to 1023 decimal value, and we have to convert to the voltage, right? And this one is basic equation for the conversion of voltage from analog input. which is the voltage reference. Usually we use 5 volts. Okay, do you agree, right? And to get the temperature degree centigrade, you just multiply the scale of the voltage we have it. So we just multiply 100 value in here. Okay, deal? I wish you understood. Okay, in here we just connect the source voltage within the middle. It is a yellow color in this picture, and this orange cable is the positive, and the white cable is negative. From diagram in here schematic, you can see clearly in here analog to means analog port pin 2 connected in the middle of the temperature sensor, and the right side is positive, and the negative connect to the ground respectively. Okay, from diagram block is similar in the previous potentiometer. In this case, we just changing the diagram pin input is analog to, excuse me, the battery. Okay, excuse me, where I am. Okay, this one is voltage conversion. We already know this one in previous slide. And in the gain, of course, you have to multiply 100 in here. Just simply multiply 100. You will get the temperature of degree centigrade. Okay, very easy. It's not difficult. Previously, we already set in here in potentiometer, right? Just change the value of the gain. And of course, in the scope, you just select configuration properties in here and convert or change it the value from 0 to 40 degrees centigrade in here. In previously is 0 to 5, right? We just change the the label, I mean. So this one is temperature video measurement using LM35. After you running the Simulink in here, you can see the degree is about 27, 28. When this graphic is will increase when you touch this sensor. This sensor will measure the temperature of your finger, of your body. My body temperature is around 30 degrees centigrade. It makes sense, right? Of course, this one is a video, and can stop this. Can I? Okay, just pause this video. Okay, for this one for next experiment. Okay, this one is similar setting in here and Simulink. You just set I already connect the LM35 and this you can see on my DeX there is the LM35 sensor in this breadboard, I mean. So in this breadboard, no sorry, in LM35 is connected into the A2 pin. Just convert again, which is multiply 100 to measure temperature. Okay, just simply like that. On the scope, of course, this one is previous measurement, and I just set this one is maybe 40, and this one is temperature. This one is Celsius. Okay, I think I'm not wrong. this one 40. Okay, and we will run this one for infinite and select external device. We don't upload this to Arduino using in here deploy instead of using run. And make sure the connection is Arduino Uno, and target, of course, COM. You can set it in here. My device is connected in the COM5. Okay, after this we just finish preparation and select the run. We need sometimes to compiling the code and do Simulink. Okay. Oh, this one show about 500. I don't know what is happening. Sorry, excuse me. That's become wrong connection. Now it's one, this sensor now shows the, forgive me, previously wrong. This one error due to wrong connection. Now it show the about temperature 27.86 degrees centigrade. Okay, from this sensor. If we touch the sensor, something like this, it will increase the temperature 30 degrees centigrade in here. All right, you can see the graph in here. Simulation measurement using temperature by simply analog input in here, and this one is gain and this one is scope. Okay, I will stop this simulation. I think you can do in your home to simulate the temperature measurement, something like this. In here you can display the name. In here you can go to display and hide automatic name. In here double uncheck this one, hide automatic names. It will show the names of your diagram block. What is this? Analog input, gain, scope, and display. Okay, very simple. For this lecture, okay, for I think we can go to next for experiment for Matlab Simulink. I wish you don't have any problem with this. For temperature measurement, you just give the conversion from from decimal number to temperature. Okay, using gain in here, and you set the analog input, whatever you put the signal, I mean the sensor. In this case, sensor is analog 2 or pin A2. Okay, and in gain, you just conversion in here from decimal value to the temperature. Voltage, this one is voltage conversion, and then for measure temperature we just, because this one linear, this sensor is linear, so if you want and you need calibration, you can set the calibration value inside in this diagram before scope. You can calibrate with another temperature or thermocouple or another thrust measurement. So you can put in the calibration value inside between gain and scope. Okay, in this case we don't do calibration and we trust and we believe the value is correct. So in here we don't calibrate our measurement. We just multiply 100 because this we believe the temperature LM35 is linear and proportional to the input voltage. So just multiply 100 in here. Okay. All right, for next experiment, we do pulse width modulation. For reminder, for you, we already learned in this previous lecture, but in this case, we study using Matlab Simulink. Okay. In previous lecture, we studied in Arduino IDE. So what is the pulse width modulation? I remind you that this one is kind of technique to create some kind of analog output signal. For example, you want to drive like a DC motor or RGB LED or anything, you can use it to control motor, DC motor, and RGB LED, or any kind of things using pulse width modulation. So in this case, pulse width modulation is generate some kind of adjustable height math period. The height output state, height output state, okay, it's commonly called a duty cycle. It's commonly called a duty cycle for high output state. So this one is usually typically a pulse width modulation signal, and this one is kind of period. We call it time period, and this one is called a duty cycle percentage. How much percentage is on duty cycle? Okay, the only height output state. So in here, this one is kind of example. 50% duty cycle. Usually give the equal space ratio. If you use 50% duty cycle, the signal between high and low is equal period of time. Okay, this one also a reminder. In Arduino Uno, for timer 1 is about 980 Hz, which is pin 5 and 6. And pin 9 and 10, timer 1, okay, with frequency generation or pulse width modulation is about 490 Hz. And timer 2, pin 3 and 11. Remember, okay? Timer 1 and timer 2 is similar frequency output. In Arduino IDE, usually we use this one analog, right? And this one is number of pin. You remember, right? And this one, 8-bit, 8-bit digital. 8-bit decimal value, not digital, sorry. This one is represent of duty cycle. Okay, they're done using Arduino IDE using analog write. In Matlab, we have another diagram block. We call it pulse width modulation. Okay, I just remind you this kind of pulse width modulation. This one is pulse width modulation output signal, respectively using duty cycle. In here, 0%, 20%, 40%, 60%, 80% is 100%, which is average analog output voltage. Typically, when you use the 0%, the analog output voltage usually 0, and 20%, the average value usually in this level, about 40% in this level, 60% in this level, 80% in this level, and 100% is maximum level, 5 volts. Okay, this one also reminder. When you use oscilloscope and measure the percentage duty cycle of pulse width modulation. And here, when you use the duty cycle 10%, the average voltage, I wish I not wrong. Maximum voltage in here 5 point, around 5 point something, 5.36, and this one 5.28. The output voltage average is 0.48, and 50% duty cycle is half of this one, is about 2.5 voltage. Okay, 90% is about 4.5 voltage average voltage. So let's begin the simple experiment in here. In this simple experiment, we want to check the shape of PWM signal regardless the time. So we just check the shape. Actually, just connect the pin timer. What is timer? Which timer is this? Timer 2, I think. No, timer 3. No, there is no timer 3. Timer 2. 11 and 3 is timer 2. Okay. So analog 1. Connect to this then to analog 1. And this one is, of course, to generate the value of duty cycle using the potentiometer. The potentiometer connect to A0. In here, I need the some kind of new cable, I guess, for this experiment. I guess we need the excuse me, we need the new cable in here. This chart. Okay, and okay, I connect to pin 11 to pin A1. I wish this one is correct. Okay, I missed something in this one. Okay, for diagram block, we just little bit complicated in here, but I wish you understand. This one is from potentiometer, of course, from A0. Okay, and set the sample time is 0.01, and for gain we want to check and see the, I don't know, this one, why need two gains in here. Maybe try to convert 100. Oh, this one, there is the pulse width modulation in here. Go here, pin 11, and this one, let's check the percentage duty cycle, and you have to convert in here 100% divided to 55. And this one is input from digital from pin 11, and this connected to A1, and this one's convert to 5 volts to decimal value. I wish I don't error in this kind of setting. Let's go Simulink in here. I do similar setting with this one. First is set and time is 0.01. Okay, and for gain we want to display to the pulse width modulation. So this one is 255. I don't know, is set the attribute signal or no? We can change this one. Can move this one. Okay, with another display, and we need to generate pulse width modulation. In here, pulse width modulation is pin 11, and just copy and paste in here. We want to display percentage of duty cycle, whatever. Yes, copy paste. This one is percentage of duty cycle. You can name it a duty cycle in here. Duty cycle. And you can copy and paste. Oh, sorry, we need gain again in here. Check the value of voltage. I am correct. Yes, I wish I am correct. Very simple setting. Okay. Okay. I wish I am correct. Check again. This one is gain, gain, gain. We can see the signal from the from this one. Did I open scope in here? And scope show the temperature in here. We have to modify the display of the voltage. I think this one is voltage. Yes. This one is voltage. Okay. voltage. Okay, everything is okay, I guess. I think we can run it, this one. Let's see what's happened. Oh, there is kind of error. Sample time must be same with the another. Let's run again. We just check the pulse width modulation signal shape regardless the time. So in here we want to see the pulse width modulation signal shape. Maybe it will take time for running. I'm waiting in here. I don't know when we'll start. Okay, I think encoder generation appear. And I don't know the scope. I think I should check again the scope. Okay. Okay, next. For the scope is sample time. Okay. Okay, we have to set this one sample time. I think it's same. Or I just leave it this experiment. Set the time is 1 and voltage in this case I think my computer is not fast enough to run this kind of simulation. I guess we have problem. Where is the video? Okay, try again. If I fail in here, I will skip this experiment. The scope display I think incorrectly in here. Oh, okay, we cannot check the signal something like this. We have to do correctly. Wait a minute, I is wrong. That's pin 11. Connect. Oh yeah, this one appear now is same. So this one is pulse width modulation signal. In here, I don't use trigger in here. You can use trigger here. when the edge is rising. Okay, and you can see the duty cycle 15, 16. Oh, duty cycle looks like not correct. Sorry, duty cycle in here is wrong. Can we stop again? This one is mistakenly put the wrong number. First mistake is wrong cable. Second mistake is the wrong number. We just want to see the signal output from pulse width modulation. Okay, now it's appear with duty cycle about 50%. This kind of shape of pulse width modulation in this simulation. Okay, you can see the what's going on in here. This one is duty cycle about 10%. You can see the shape of the pulse width modulation 20%. Okay, in here 20%, something like this, and 30%. I wish something like this, and 40%, 50%, and so on. 60%. It will go to 5 if you set the maximum. This one is 80%, and this one is 90%. Okay, this one is 90%, and it will flat 5% if you set duty cycle 100%. That is pulse width modulation. We can change it, signal value. If 0 is of course 0. Okay, that one is pulse width modulation example. And stop this. Let's go back to presentation. Something like this. And this one is kind of video, similar video we already did. When you rotate this tensiometer, it will show the signal shape of pulse width modulation for this simulation. I don't check the time in here. I wish the time is, I guess this time is not correct, this one. If you want to check real pulse width modulation, you can use the real oscilloscope. But in this limit device, I just simulate this kind of shape regardless the time. We just want to see the shape of pulse width modulation. I hope you can forgive me. And I think in this lecture, we just want to see the shape of pulse width modulation, regardless the accurately the time. Okay. Okay. I wish you understand what is the duty cycle is going on in using Matlab Simulink. In here, in previous lecture, we can see the shape of signal also using Arduino IDE. And Arduino IDE provide also the kind of plotter, serial plotter. So we just can plot there from serial plotter. In this simulation, Matlab Simulink, you can see from the scope in here. Okay, can I go to next experiment? I wish you understand and pulse width modulation Okay. Okay, next experiment. Okay, for next experiment is we want to fading LED in here. We have a LED connected in the pin 11, and we have resistor 220 ohm connected to green LED, and the black is the ground. Okay, for this experiment I will skip this for next video. I will cut this, and for next video I will explain this experiment for. Okay, we now in experiment 4. What is the experiment 4? Experiment 4 is fading LED. And this LED connected to the pin 11, and potentiometer is connected to the A0 pin. Just simply like that, very simple. Okay. And in diagram block, of course, you have to very simple diagram block actually. You have the input, analog input, potentiometer, pin 0. Excuse me. And the sample time 0.01 second. It means 10 millisecond. I'm not wrong. Am I wrong? That's correct. Okay. And again, you have to convert, because this pulse width modulation input is 0 to 55, right? This one is represent duty cycle. 0 is 0%, is 255 is, I'm sorry, 100%. So we just convert this, the value input. This value input is from this number, right? 0 for 1000. From 0 to 1023 decimal value. We want just convert 0 to 55 decimal number and go to this the PWM diagram block, and we have a scope in here, we have display in here, and this one I think diagram block is very simple. And for scope there is select configuration properties, very simple, and select the in here, I mean maximum and minimum value. Minimum value is 0 and maximum value 255 decimal value. Okay, I think it's very easy to set the scope. And this kind of video, you can see the LED will light depends on voltage input from pulse width modulation. You can see the value of the number decimal value. This one 200, 250, and 255. And 255 means maximum voltage, and can lower value, and then off LED. This LED on depends on the value of the decimal value in here. Okay. Okay, let's begin our simulation. I will open my old folder. Maybe this folder doesn't save, just leave it. In here I have LED pulse width modulation, namely. Can I close this scope? Okay, this diagram block is similar in used in presentation. Okay, and I already installed the LED, and this one is green LED connected to pin 13. Okay, I'm sorry, pin 11. Pin 11. Pin 11 connected to pin 11. Can I see the PPT previously? Pin 11. So I have to change it to pin 11 in here. Oh, where is it? Oh, my video doesn't appear. Sorry, this one is so annoying. Okay, I connected to the pin 11, I guess so. And all right, nothing wrong. Open the scope in here. And this one is, I don't have too much for display. I guess this one is okay for you. Okay, maybe just check the option. The same is manually COM5. Infinite and external, and we can run the simulation. We have to wait simulation for compiling and building the code for external simulation. In this case, for Arduino, you know. Still building until a code generation will appear. Okay, it takes a few sometimes, and can see now it's running, maybe. And I think we can rotate this potentiometer. As we can see, the LED is turned on according to the value of the pulse width modulation signal. In here, this one is maximum. Maybe, okay, this one is maximum. And we can change the value of LED according to the rotation of potentiometer. Okay, I rotate like this. Okay, this one is pulse width modulation example for fading LED from brightness changing maximum to minimum value. Okay, I wish you understand. This one is simulation for LED using pulse width modulation. And you can see the display in real time. This one almost 0. Okay. Can stop this one. Okay, now simulation is stopping. Okay, let's go back to presentation. This kind of fading LED example, I think very easy for you. I repeat again the diagram block in here. Okay, we use the analog input and set the pin A0 and also set sample time about 10 milliseconds. And also you need some kind of gain diagram block in here in the middle, which we have to convert from 1023 maximum value to 255 decimal value, go to the pulse width modulation in here. Okay, and the scope is just for monitoring the signal output from gain to diagram block pulse width modulation. This pulse width modulation, we set the pin 11 in here, which is very easy. You can set in here. And this unit also display in here and scope. Okay, for scope configuration, you just set similar sample time from analog input in here. Okay, agree, and just see the decimal value 02255. This kind of video explaining the changing the potentiometer value by rotating it and changing the brightness of the LED based on the pulse width modulation signal. Okay, I think this one is very easy experiment. All right, we arrive now at last experiment. That is experiment 5. I took example from your previous homework. From the textbooks, your textbooks is very awesome. I mean, we can take this example from Matlab Simulink. From this example, we know that analog input and this potentiometer is connected to the pin A0, okay? And the red, green, blue LED is connected in the pin 11, 10, and 9. The red pin is connected to the timer pin 11 and the green connected in the pin 10 and blue pin is connected in the pin 9. Okay, in this program, nothing special. We don't. I mean, I don't explain this program, but basically we want to rotate the potentiometer when the value of the pulse width modulation value less than equal 128. There is combination color red and green. This kind of combination color, I think this one is not important. This kind of part, this red and green, which is blue is 0, which is red is this equation. Okay, and the green is based on the red value. And if the value more than 128 in here, red is 0, and this one is not important. Can remove this. And this green is this equation, I mean, and the blue is depends on green value. And we write pulse width modulation in here, and I think in Matlab Simulink we don't need a delay in here. Okay, all right. I wish you understand my explanation. Okay, for next main diagram block in Matlab Simulink, this one is not complicated. I just make it this one simple. This one is normal, I guess. Okay, now we have to set this one a 0. Okay, and this we need gain. We need convert to decimal value. So we need this conversion. So we just need if and else if condition. In here, if less than 128, go to this subsystem, and more than this, go to this action subsystem. I mean. And this one also input in here, and this is also there is input, go through here. And this kind of signal is merge each other and then go to the pulse width modulation diagram block. It is red is 11, green is 10, 9 is blue. Okay. In if subsystem, which is the bigger than 128. Okay, deal. First is if and is else if. If the value bigger than equal 128, it means this part. So what is blue? Blue is a 0. Okay, this one is blue. Set the 0 in here. And what is the green? Green is based on the value 255 minus red. So we have constant value here, 255, which is the red. We want to see the red. This one is basically already signal red in here, signal red. So this one is constant value. If you read this one is go through here. This one is 255. It's constant, right? So this one red. This one's red. So this one green is 255 minus red. And in here we have the R definition, which is 255 minus 255 odd value. Odd value, what is odd value? This one input value. Input value in this case. Okay. Convert to this gain is 255 divided to 8. And this one is simply just 255 minus this kind of part. Okay, I think this one is right. It's very easy. 255 minus gain multiply input value. This gain is 255 divided 128. It's the same like this equation. Alright, it's not difficult. Okay, I erase this one. This one is if subsystem. And in else if subsystem, this one else if bigger value 128 deal. It is similar in here. So what is red? Red is 0. We set red is 0. Okay, very simple. And we have a blue. Blue is constant minus green, which is in here constant value. This one is constant value 255 minus green. As the result, the signal is 255 minus green in here. And what is green? Green is constant 255 minus this signal. And this signal is input minus 128. Input minus 128 multiply 255 divided this one. 255 divided 128. Okay, so this one is basically gain multiply input minus 128. Okay, that is a green, and we just make a else if subsystem. In this case, for bigger than 128 value. And this one is gain for a main diagram block. Set the value in here. Of course, convert in range 0 to 55. And the data type in here set from unsigned integer 8. Otherwise, it's some kind of fail because this if block condition need MATLAB data. This one is should be MATLAB data. MATLAB data. Okay. Okay. Everybody understand? Okay. For scope configuration, in here we set must be same for analog input for 10 milliseconds, and display is we display decimal value for 0 to 255. Excuse me. Before simulation, you can set the time for infinite, INF in here, infinite, and using external device, which is Arduino Uno. Okay, this one is diagram block from RGB LED in our final experiment in this lecture. Go to next. We have to set in option some kind of for uncheck in this for multi-text timer. Previously this one is checked. You have to uncheck this one, uncheck this one, and for data validity, diagnostics, select data validity, and detect precision loss in here, select none. For off the warning, for precision loss. Okay, and just select run for start for simulation. And this kind of video, this one RGB is 0 and changing the value, the more than 128, this combination green and blue in here, and then become blue, and this one is green, right? Blue, green, blue. Okay, and 0 of course red. Okay, very simple. Okay, this one is your homework, previous homework actually, homework 6, I mean homework 6, if I'm not wrong. This card, okay. And in here I can close this one, and open. I don't want to make in here. I already have a Simulink diagram block in here, and in here set the pin number A0 and set time 0.01. Okay, for gain conversion from to pulse width modulation, we set the 255 for maximum, right? And signal attributes, you select this one, unsigned integer 8. There is kind of data type in here. In my case, I select this one to go through the if condition. This one is if, input numbers is if, and this one is expression less than equal 128 and bigger than 128. Just simply like that. Okay, nothing special. And you add this if subsystem in here. I already explained in if subsystem, you have some kind of this algorithm for red, green, and blue. Blue is 0 and green is 255 minus red, and this red is input multiply 255 divided to 128. Okay, and this one 255 minus this kind of signal, and this one is red. Okay, and this one for else if condition less than bigger than 128. For this else if is combination between green and blue, so red is 0. Okay, red is 0, you just type constant in here, and blue is 255 minus green signal. In here you just give this summation block in here, and green is input signal minus this constant, and then multiply this gain. Okay, this one is green. 255 minus this signal. This one is green. Okay, nothing special. And you have to merge this signal. For red is with red, green with green, and blue with blue. And then go to the pulse width modulation diagram block. In this pulse width modulation diagram block, you can see the value is only accept between 0 to 255. Okay, 0% duty cycle represents 0, and the value 255 produce 100% duty cycle. Okay, everyone agree, right? Okay, you can name it this one, red and green and blue. Pin 11, 10, and 9. Alright, for scope, okay, already. For scope is nothing special. Firstly, you have to set this time, and you can check or uncheck in here, open at simulation start. Okay, for time, I set the time span is 1 in here, and then scroll. Time unit is metric, maybe based on time span. And display, active display is of course single input, and the value y limits minimum is 0 and maximum y limits is 255 decimal value. And I don't check it, this one, and nothing on it. And this one is just like that. Just like that. And you have to check the connection for this COM. Okay, in my case it's COM5. I set manually in here, and diagnostic in here. For data validity, detect precision loss, select none. Okay. For solver, previously usually check this one. You should uncheck this one. Treat each discrete rate as pairwise text. So means that it multi-text. I think so. And you can run this one, I guess. I wish a success. And in my desktop, I already installed this one RGB LED. You can see this one is RGB LED and potentiometer, which is connected to the A0, which is RGB LED connected to pin 11 for red, 10 for green, 9 for blue, respectively. I already connected this one. Okay, now simulation is running, and the value is 0, means red. If we display is 1. If we rotate this one, you can see the RGB LED changing based in the value of pulse width modulation. Okay, this one is already higher than 128. This one is 128, is green color. Okay, and it will change to become blue color for 255. Okay, this one is color of yellow or white. I think yellow, and goes through red color for analog input 0. I mean the value is 0. Okay. Okay. I wish you can do this experiment at home. Okay. And follow the instruction from the PPT slide. I just rotate up and down and see the color changing of the RGB LED. Okay, this one is our last experiment. For this lecture, I wish you can understand the principle and diagram block, of course, in Matlab Simulink. And go back to PPT. Okay, this one our final experiment. Can see the video again. This one is RGB LED experiment using potentiometer. The RGB LED will change the color based on the value of potentiometer in here. Okay. 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 In this final lecture, there is no homework for you, and I wish you understand how to get analog input from potentiometer, especially. And I wish you understand in this using Matlab Simulink for simulation. Thank you for your attention, and I wish you understand my lecture and have a good day. Thank you very much.